All right, so let's go to the B part of the question. The B part says, a person at the top of a lighthouse, TB, sees two ships, S1 and S2, approaching the coast as illustrated in the diagram below. The angles of depression are 12 degrees and 20 degrees respectively. The ships are 110 meters apart. We're to complete the diagram below by inserting the angles of depression and the distance between the two ships. Well, that's not difficult to do. Angle of depression, as you should remember, is the angle between the horizontal and the line of sight when you're looking down. So the person is at T looking down at what? At the ship S1. This line here is the horizontal. Now the angle of depression is the angle between the horizontal and the line of sight when you're looking down. Now here, this will be the line of sight of the person at T looking down at the ship S1. The angle of depression would be the angle between the horizontal and the line of sight. That angle there would be 20 degrees. And of course, the 20 degrees will be more than the 12 degrees. Additionally, the distance between the two ships is 110 meters. So we were to what? Complete the diagram by inserting the missing angles of depression and the distance between the two ships. Next, we're asked to what? We're asked to determine to the nearest meter the distance, to determine to the nearest meter the distance TS2. We're to determine to the nearest meter the distance TS2. All right. TS2. TS2, that's this distance here, let's call it X. You want that distance, TS2. All right. This angle here is 8 degrees. So let's call it theta. We're going to explain all that to the examiner again. All right, in order to do this, I need to find this angle here. This angle here, alpha, is 12 degrees. This angle here is 12 degrees. Sorry, let me take out the 12. This angle here, alpha, is 12 degrees. All right, and I have to explain all of that to the examiner. In order to solve it, I need to find this angle here. Let's call it beta. So let's start to solve this question now. I would say to the examiner that theta, now I'm the one who put in theta, is equal to 20 degrees minus 12 degrees is equal to 8 degrees. I would explain to the examiner that alpha is equal to 12 degrees. They are alternate angles. All right, see it there? You can see it, it's like that. The alternate angles are Z angles. So if this is 12, this one is also what? 12. Alpha is 12 degrees, they are alternate angles. Now, beta is equal to 180 minus the 180, and I didn't even have to go this route, you know, but we started already, so let's finish it. Minus 8 degrees plus 12 degrees. And these are the interior angles of a triangle. So interior angles of a triangle. So beta would be equal to 180 minus 20, which is equal to 160 degrees. Now, if I know The next thing I'm going to apply is I'm going to apply the sine rule. All right, so I know what, actually know all three angles in the triangle, and I know one side. First of all, T S1, S2 is a non-right angle triangle. And the tools for solving a non-right angle triangle are sine rule and the cosine rule. 1 and 2. 3, you can only use the cosine rule when you know at least two sides. So if you only know one side, it means that you must be using the sine rule. I always tell people, whenever I'm using the sine rule, I always start out with what I want. So x is what I want. I'm going to say x over the sine of the angle opposite to x. The angle opposite to x is what? Beta. So it's the sine of 160 is equal to the 8th degree, is equal to the 110 meters, which is the side I know, over the sine of the angle opposite to that side, which is 8 degrees. I'm sort of going to do a half cross multiply and bring this over here. So x would be equal to 110, the sine of 160 degrees divided by the sine of 8 degrees. Now, all I have to do is put this in my calculator and press equal. And so x would be equal to 110, the sine of 160 degrees. And this now is divided by the sine of 8 degrees. And the answer is x. So x, which is TS2, my calculator is saying 270 meters. 270 meters. And of course, that is to the nearest meter. It's actually 270.3, but they said they want the answer to the nearest meter. All right, so let's move on to finish the question. All right, so next we're asked to calculate the height of the lighthouse TS. Normally that would not be very difficult. The height of the lighthouse TS. So now I have this side is 270 meters. Over here is what we want to find, the height TS. Answer this. What is this side TS to the 12 degrees here? The side TS to the 12 degrees is opposite. The side, it's TB, it's opposite. And TS2 is the hypotenuse. Now, the ratio that includes opposite and hypotenuse is sine. So I would say sine of 12 degrees is equal to opposite y over hypotenuse 270 degrees. If I have one fraction is equal to one fraction, I would cross multiply. So y is equal to 270, the sine of 12 degrees. Therefore, y, which is TB, is equal to is equal to 56 meters. And of course, that is to the nearest meter. So TB is equal to 56 meters to the nearest meter.